So today what we're going to be working on is solving rational inequalities. So I'd like you to put me on pause and do the try this and then come back and check your answers. Okay, so for the try this, it is solving a rational equation. So remember, when we solve a rational equation, we want to eliminate the denominators. So I multiply the denominators by the factors of multiply all the numerators by the factors of the denominator. So I have a 3 and a 4, so I need a 12 up top in the numerator so that it factors and becomes a 1 in the denominator. So I'm going to multiply all the numerators by 12. And I need to get rid of the x in the denominator, so I'll multiply by x also. So I'm multiplying all the numerators by 12x. So now I'm going to reduce. So 3 and 12 reduce to 1 and 4. X and x reduce, so I'm left with to 1 and 1. So I'm left with 24, that's 4 times 6. 4 and 12 reduce to 1 and 3. So then I'm left with plus 15x, that's 3x times 5, equals x and x reduced to 1 and 1 equals 36. So then we subtract 24 from both sides, so I get 15x is equal to 12. Divide both sides by 15, we get 12 over 15, which is equal to, that reduces by 3 to 4/5. And then, of course, when we have rational inequalities, just check the denominators. Make sure that you don't get anything undefined when you plug x in. So here I have 3 times 4/5 is not 0, and that's just 4/5, so I'm all good. So 4/5 is a good answer. All right, so now we're going to work on the inequalities. All right, so let's see what we have to do. So the first thing you want to do is find what's called the critical point. The critical point is when the denominator is equal to 0. So it's when the fraction is undefined, okay? Then you're going to change the inequality to an equal sign, so then you're going to solve it just like we didn't do now. It's going to be a rational equation. So you're going to solve as you would for the fractional equation. You're going to draw a number line. You're going to plot the critical point. When you plot the critical point, that's going to be an open circle because, remember, the critical point is when it's undefined, so it can't be that solution. So it'll be an open solution. And then the other solution you're going to get from when you solve the equation, that circle will be dependent on what's the original problem. If it's less than or equal to, greater than or equal to, it's a solid circle. If it's just less than or greater than, it's an open circle. Then you're going to pick test points in each interval on the number line. And then you're going to check your test points in the original inequality to determine where to shade. All right, and of course you need to make sure that you know how to represent the solution in multiple ways. All right, so let's take a look at number 1. So the first thing I'm going to do is to determine when is the inequality undefined. That's the critical point. So write that on the side. So the critical point, when x is equal to -5, then it's undefined. Right? So x plus 5 equals 0. X is undefined, so it's equal to 0 when x is equal to -5. So I'm going to rewrite this. I have x minus 4 over x plus 5 is equal to 4. Put 4 over 1 and cross multiply. So I have 4 times x plus 5 equals x minus 4. Distribute the 4. 4x plus 20 equals x minus 4. Minus x from both sides, I get 3x. Minus 20, I get -24. Divide by 3, I get -8. Okay, so now on the number line, so you're going to draw a number line. And you're going to plot -5 and -8. Now, your critical point is always going to be an open circle because, remember, it can't be that number. And we have -8, and that's an open circle because my inequality does not have an equal sign underneath. Okay, so now you're going to pick test points. You're going to pick a number to the left of -8. So I'm going to try -9. You're going to pick a number in between -8 and -5. I'm going to use -6. And a number to the right of -5, I'm going to pick 0. I always like to pick 0, 1, and -1 if they're available. If they're not available, then you can't pick them. All right, so now what you're going to do is you're going to plug each point in, each number in, and evaluate into the original inequality up here. Okay, and yes, you're using the inequality sign. All right, so I'm going to plug in now -9. So I have -9 minus 4 over -9 plus 5. Is that less than 4? It's like a check to see if it works. So -9 minus 4 is -13 over -4. Is that less than 4? So -13 divided by -4 is 3.25. That is less than 4, so that works. That's check. So that means I shade to the left of -8. Now I'm going to try -6. So I have -6 minus 4 over -6 plus 5. Is that less than 4? So I have -10 over -1 is less than 4. Is 10 less than 4? That's not true. So we don't shade in the middle. Now you try 0. 0 minus 4 over 0 plus 5. Is that less than 4? That's -4/5 is less than 4. Of course that's true. A negative is less than a positive. So I shade to the right. So this here, right here, this is called a graphical solution. Now you should be able to write the solution as use an interval notation. So over here on the left, I would have from -infinity to -8. And that's an 8, even though it doesn't look like an 8. So to -8, parentheses, union, because then we need this side over here, -5 to +infinity. Okay, so let's flip it over and take a look at what's on the back. Okay, so number 2 says 2 minus 3 over a is greater than 5 over a. So the first thing is we find that critical point. That's when my denominator is equal to 0. So a cannot be equal to 0 because then it's undefined. All right, so I'm going to rewrite this as 2 minus 3 over a equals 5 over a. So I want to get rid of all the a's, make all the a's 1. So I'm going to multiply everything by a. So multiply by a, and a. So I get 2a minus, the a's here reduce 3, equals a and a reduced to 5. So I get 2a is equal to 8. A is equal to 4. All right, so on your number line, you're going to plot 4 and 0. So I have 0 and 4. The critical point is an open circle. 4 is also an open circle because my inequality is a greater than symbol. Now you're going to pick test points. Pick a number to the left of 0, -1. Pick a number in between 0 and 4. So we'll pick x equals 1. And to the right of 4, we'll pick 5. All right, so we're going to start with -1. So I have 2 minus 3 over -1 is greater than 5 over -1. So I have 2 plus 3 is greater than 5. 8 is greater than 5. That's true, so that means we shade to the left. Now we're going to try 1. 2 minus 3 over 1 is greater than 5 over 1. So 2 minus 3 is -1. Is that greater than 5? No, a negative is not greater than a positive. Then we're going to try 5. So I have 2 minus 3 over 5. Is that greater than 5 over 5? So 2 minus 3/5. So you can use your calculator. 1.4, is that greater than 1? That's true, so therefore I shade to the right. So my solution, that's graphical solution. So my solution as a using interval notation would be from -infinity to 0. Union 4 to infinity. Okay, so let's take a look at the last problem. Okay, so the first thing we're going to do, remember, is find the critical point. So what can't your x be? X cannot be equal to -1 because then it's undefined. Now rewrite it. So I have 2 minus x over x plus 1 equals 3 minus 9 over x plus 1. So I want to get rid of the x plus 1, make it equal to 1. So multiply everything by x plus 1. All right, so let's see what I have here. I have 2 times x plus 1. X plus 1 and x plus 1 reduced to 1, so I'm going to have minus x equals 3 times x plus 1. X plus 1 and x plus 1 reduce, so I'm left with minus 9. Distribute, I get 2x plus 2 minus x equals 3x plus 3 minus 9. So 2x minus x is x plus 2 equals 3x. 3 minus 9 is negative 6. Minus x from both sides, I get 2x. Add 6, I get 8. Divide by 2, I get 4. Okay, so let's see. So I'm going to draw a number line. And I'm going to plot negative 1 and 4. 4 is my solution. That is a closed circle because my inequality has the equal sign underneath. And my critical point is obviously an open circle. All right, so we're going to pick test points. Pick a number to the left of negative 1, like negative 2. Pick a number in between negative 1 and 4. 0 is a good number. And a number to the left of 4, I'm going to pick 5. So now we're going to plug it in to the original. So it's 2 minus negative 2 over negative 2 plus 1 is greater than or equal to 3 minus 9 over negative 2 plus 1. So I get 0 is greater than or equal to 12. Is that true? That's not true, so I don't shade in the middle. Now we're going to try 0. 2 minus 0 over 0 plus 1 is greater than or equal to 3 plus 9 over 0 plus 1. So I have 2 is greater than or equal to negative, oh sorry, that's a minus in there. Sorry, this is a minus in here. Minus. So that's negative 6. So is 2 greater than negative 6? Yes, that's true. So that means I shade in the middle. Now I try 5. So I have 2 minus 5 over 5 plus 1 is greater than or equal to 3 minus 9 over 5 plus 1. So plug it in your calculator. So I have 1.16, that's repeating, is greater than or equal to 1.5. That is not true. 1.1 is not greater than 1.5, so that's not true. So I don't shade there. So that's my graphical solution, and my solution written as an interval, using interval notation, would be negative 1, comma, to 4, inclusive. So use a bracket. Okay, so that's it, and we'll practice in class tomorrow. Everyone have a good night.